Learning Target 5 says I can model and solve problems about real-life situations using polynomials. So sometimes in these problems I might give you an equation that describes some real-life situation, and you need to use that polynomial to solve some problems. In other cases you might not be given a polynomial and have to come up with the polynomial in order to solve the problem. So in problem number 1, I'm actually giving you an equation and you're going to answer some questions about it. So in this problem we have that Taj is playing basketball. He's right behind the 3-point line when he takes a shot. He obviously almost never misses, but just this once he does. If x is the horizontal distance from Taj to the ball at a particular time, this polynomial h of x describes the height of the ball at that time. So part A asks us to sketch a picture of this situation, which is always a good idea in a word problem, even if you're not asked for it. So let's draw ourselves a little picture of what's going on here. So here we have Taj, and Taj is playing basketball. And so Taj shoots the basketball, and just this once it ends up landing on the ground. Now we're told that x describes the horizontal distance from Taj to the ball at a particular time, and h of x describes the height of the ball at that time. So imagine that the ball is up here at a given point in time. X is this horizontal distance away from Taj, and h of x describes the height of the ball at that time. Now, in part B, it asks us, we want to know how far away from Taj the ball lands. Write an equation you could solve to find out. So, what we want to know is, what is this distance here between Taj and the ball? So to solve that, we want to think about what is x, what is the horizontal distance away when the ball hits the court. But when the ball hits the court, the height off the ground better be 0. So what we need to solve is, what is x when h of x is 0? So an equation we could solve would be just to set h of x equal to 0. And we want to solve this equation for x. Now part C asks us to now solve our equation, and it gives us a hint. When factoring, you might want to pull out a GCF of -1, just because you aren't used to factoring with a negative in front of the x squared. So we know that to solve an equation, we first want to get all the terms over to one side, set equal to 0. We're actually already all set with that. Our terms are already off to one side, set equal to 0, so we don't need to move anything around. Our next step is going to be to factor the polynomial in order to be able to use the zero product property eventually to solve. But to factor, you guys just aren't normally used to having a negative in front of the x squared, so that's why I gave you this little hint. When factoring, you might want to pull out, sort of treat -1 as a greatest common factor and sort of pull that out of the equation so that you end up with something without the -1 in front of the x. Or the x squared, rather. So let's see how that would work. So let's imagine we're pulling a GCF of -1 out. Now remember, when we factor out a GCF, we want to think to ourselves, okay, what needs to be left inside these parentheses so that whatever we have here would actually multiply out to give us this. So we need to think to ourselves first, -1 times what would give us a negative x squared? Well, we would need an x squared on the inside here. Then -1 times what would give us a positive 18x? So we would need a minus 18x here. And then -1 times what would give us a positive 40? So we would need a negative 40 here. Now remember, the next step in factoring is to keep factoring whatever is left inside the parentheses. So if you notice, this is a monic quadratic, so we can set up a nice little multiplication box to factor that monic quadratic. Now remember, our x squared will go in the top left box, our negative 40 will go in the bottom right, and then these other two boxes will be something times x, and we need to figure out what those numbers in front of the x's should be. So when we're talking about a monic quadratic, we know that these two numbers have to multiply to give us a negative 40 and add to give us a negative 18. So two numbers that I'm thinking of are 20 and 2. Those would multiply to make a positive 40, so we need one of those to be negative. If we make the 20 negative, then when we add up negative 20 and 2, we'll get the negative 18. When we multiply, we'll get the negative 40. So I'm going to pick one of these spots to put a negative 20 and one of these spots to put a positive 2. So next I want to fill the outside of my multiplication box. I know that this x squared had to have come from multiplying an x times an x. Then to figure out what number should go up here, I can think to myself, okay, x times what would give me a negative 20x. So up here we better have a minus 20. And then down here, I can think to myself, well, what times x would have given me a 2x? So this down here better be a positive 2. And then I can check for myself, okay, does the positive 2 and the negative 20 actually multiply to make a negative 40? And it does, so that checks out. So the next thing I'm going to do is I'm going to rewrite my equation in my sort of newly factored form. And now that this is factored, I can use the zero product property to solve. So the zero product property says that if I have a product of a bunch of things that are equal to 0, then at least one of those factors has to be 0. So my options are either negative 1 is equal to 0, which that one just doesn't make sense, or x plus 2 is 0, or x minus 20 is 0. So x plus 2 can be 0 when x is negative 2, and x minus 20 can be 0 when x is equal to 20. So my two possible values for x would be negative 2 and 20. Now part D says, remember, x is supposed to represent the distance the ball is away from Taj. Cross out any x values in your answer to C that don't make sense as a distance. So if you notice here we have x equals negative 2 and x equals 20, it wouldn't make sense to have a negative distance, so this x equals 2 doesn't make sense within the context of the problem. So we must have that x is equal to 20. And what that means is that the ball is 20 feet away from Taj when it lands on the court. And just in case you're curious, the reason why we got that extra little x value of negative 2 is because in this picture, see how the trajectory of the ball is modeled by a quadratic equation? Basically, the negative 2 comes from finding this other spot over here where your height would be 0 if the parabola actually was finished up. We were actually looking at like the entire parabola. So that's why you get that extra little x value of negative 2. It's just that in the context of this problem, that x value does not actually make sense. So we have found that the ball is 20 feet away from Taj when it lands on the court. Now let's move on to problem number 2. So problem number 2 is this problem about Richard building a cabinet. So I know that we talked about this one in class, but I wanted to go over it again in this video because it is an important type of problem. So in this problem, we have Richard building a cabinet, and we're given some information about the cabinet. Eventually, we're going to try to find the dimensions of the cabinet based on all the information that we're given. So the information we're given is that the height of the cabinet is 4 feet more than the depth, and the width is 2 times the depth. X, we're told, is the depth of the cabinet in feet. And for this first part, we want to find the height, the width, and the volume in terms of X. And actually, I realized that I asked for the volume in part B, so let's just ignore that part where it asks us for the volume. We'll ignore that for now. Okay, so if X is the depth of the cabinet in feet, we want to find the height and the width in terms of X. So, we're told in the problem that the height is 4 feet more than the depth. So if the depth is X, then our height is going to be X plus 4. We're also told that the width is 2 times the depth, so the width is going to be 2x. Because again, we're saying that the depth is x. So the next part, in part B, it asks us to find the volume in terms of x, multiply your answer out, and simplify as much as you can. So remember, the volume of a rectangular prism, we're going to take those 3 dimensions, the height, the width, and the depth, and we're going to multiply those together. So our volume will be equal to the depth times the height times the width. And we want to multiply those together. Now, and simplify as much as we can. Now, we're multiplying together 3 things, so I'm just going to start by multiplying 2 things together, and then take whatever we get from that and multiply by my 3rd thing. So I have x times x plus 4. I'm going to use distribution and multiply my x first by my x, and then I get x squared. And then I'll multiply my x by my 4, and that gives me plus 4x. But remember, this just comes from these 2 being multiplied together, so I still have to multiply by my 2x. Now, I can again use distribution. I know the 2x is off to the right, but I can again use distribution and distribute my 2x. And when I multiply, 2x times x squared will be 2x to the 3rd, and 2x times 4x will be 8x squared. So my formula for my volume is just 2x cubed plus 8x squared. In part C, it tells me, let's see, so the volume is 24 times the depth, and it asks how else can you write the volume in terms of x. So again, remember that the depth is just going to be x. So if we're told that the volume is 24 times the depth, then the other way we could write the volume would just be 24x, because the depth is x, and we're told the volume is 24 times the depth. Now part D asks us to use your answers to B and C to write an equation you could solve for the depth x, then solve for x. So first let's think about writing an equation that you could solve for the depth. Now in part B and in part C, you came up with 2 different equations, 2 different formulas for the volume in terms of x. If these are each supposed to be equal to the volume, and we're talking about the same cabinet, those 2 volumes had better be equal to each other. So we can write an equation that looks like 2x cubed plus 8x squared is equal to 24x. And that's going to be an equation that we're going to be able to solve for our variable x. Now, whenever we're solving an equation, our first step is going to be to get all of our terms over to one side set equal to 0. So first I'm going to subtract my 24x from both sides so that I have all my terms on one side set equal to 0. Now after I do that, remember that I want to factor this polynomial part so that I can eventually use the zero product property to solve for x. So the first thing I ever do in any kind of a factoring problem is I try to see if there's any kind of a GCF that I can factor out of all three terms. Because if I can factor out a GCF, that sort of makes my factoring job a lot easier. So let's look at these three terms and see if we have a GCF. So looking at the numbers parts, we have a 2, an 8, and a negative 24. So 2 is definitely a factor of all of those. Oops, I sort of gave it away. 2 is a factor of all of those. Next, looking at the variable parts, we have x cubed, x squared, and x. So they all have at least one x in them. So we can pull out a 2x. Now we next need to think about what should go on the inside here so that if we were to, multiply by the 2x, it would actually be equivalent to this expression here. So first, let's think about 2x times what would give me a 2x cubed. Well, I would have to multiply by an x squared to get from 2x to x cubed. So I have an x squared left inside these parentheses. Next, let's think about 2x times what would give me an 8x squared. Well, to get from 2 to 8, I'm going to have to multiply by a positive 4. And to get from x to x squared, I'll have to multiply by an x. Finally, I want to think to myself, 2x times what would give me a negative 24x. And so to get from 2x to negative 24x, I'll have to multiply by a negative 12. Now, I next want to think about what I have left over inside these parentheses and think about if I can factor that further. So inside these parentheses, I have a monic quadratic. So I am going to use a little multiplication box to see if I can factor that any further. So I know that my x squared will go in my top left box, my negative 12 will go in my bottom right, and the other two boxes will be some number times x. And I need to think to myself what numbers should go in front of those x's that would multiply to make a negative 12 and add to make a positive 4. So remember, with a monic quadratic, the numbers that will go in front of these x's will multiply to make a negative 12 and add to make a positive 4. So the two numbers I'm thinking about are a 6 and a negative 2. Those will multiply to make multiply to make a negative 12 and add to make a positive 4. So I'm going to pick one spot to put my 6 and one to put my negative 2. So then I'm going to try to fill out the outside of my multiplication box. I know my x squared came from multiplying x times x. Then I can think, what do I need to put up here so that I would have gotten a 6x on the inside here? So I need to think x times what would have made 6x. So I'll need to put a positive 6 up here. By the same sort of reasoning, I know I need a minus 2 down here. So my two factors are going to be x plus 6 and x minus 2. So I'm just going to rewrite my equation with those two factors. So now I have an equation that's nice and fully factored, so I can use the zero product property to solve. So zero product property says if I have a product of a bunch of things set equal to 0, then at least one of these things has to be equal to 0. So I'm just going to set each of those equal to 0. Either 2x is 0, or x plus 6 is 0, or x minus 2 is 0. And I can solve each of those equations for x. So solving this equation for x, I'll divide both sides by 2, and I get x is 0. Solving this equation for x, I get negative 6, and solving this equation for x, I get a positive 2. So these are my 3 possible x values. But within the context of this problem, remember that the x is the depth of a cabinet. So we need to think about like which of these x values actually make sense within the context of the problem. So it doesn't make sense to have a depth of 0, because then the cabinet wouldn't exist. It also wouldn't make sense to have a depth of -6. What would a depth of -6 even mean? So we can also eliminate that possibility for our x value. So we're just left with a possible depth of 2. So the depth of our cabinet will just be 2 feet. So our last question asks us to use our answer to part E to find the height and the width of the cabinet. So if we go all the way back to the beginning, remember we said that our height was 4 more than the depth. So if our height is 4 more than the depth, 4 more than 2 would be 6. We also knew that our width was 2 times the depth. So if our width is 2 times the depth, then our width needs to be 4 feet. So Richard is building a cabinet with a depth of 2 feet, a height of 6 feet, and a width of 4 feet. So just to quickly review what we did in this problem, because it was a bunch of parts, we used all the information given to us to figure out 2 different formulas for the volume of the cabinet. Since these were 2 different formulas for the volume of the same cabinet, we knew that those 2 volumes needed to be the same, so we were able to create this equation that we were able to solve for the depth x. We solved that equation by factoring and using the zero product property. Then we eliminated the x values that didn't make sense in the context of the problem. Once we did that, we were able to figure out exactly what the depth was equal to, and then we were able to go back and solve for the other dimensions of the cabinet.